All right. So now we're going to do some exercises here. Okay. So here's the equation, and we know that it's in the Bernoulli form because y, it's not going to be a linear differential equation because the n in here is not 0. It's not going to be able to be separable variables because the n here is not 1. N is equal to minus 3. Okay. So we got to multiply, we got to make this go away. So we're going to multiply everything by y cubed. So y cubed, y prime, right, plus x, y to the fourth equals x e to the minus x squared. And there you go. Okay. Now, I'm just going to put over here the general formula is going to be y to the 1 minus n is equal to e to the negative of the integral of 1 minus n px dx. Everything times the integral, I'm going to put a times in here, of 1 minus n q of x. All right, and hold on, e to the minus integral 1 minus n px dx times this stuff times e to the integral 1 minus n e of x dx, and now we're going to integrate everything dx. Okay, so let's worry about this thing now. Well, actually it's this one. Okay, so it's going to be u, because this is of x, u of x, which is the integrating factor, is going to be equal to e to the integral of 1 minus n. Well, n in this case, in here it's minus 3, so 1 minus minus 3, 1 plus 3, 4. Okay, so 4 px. Now what is px? Px in this case is this one, right? So you have that px dx. Now if you're going to do that, it's going to be the e, all right? Oh no, you're not going to integrate that. You're just going to, so you see, what is this integral? I'm sorry guys, because I thought I was integrating everything like this, but I'm not. I'm just integrating that stuff. So this is e equals. Now, the integral of 4x dx is going to be 4x squared divided by 2. So it's going to be 2x squared. So this is e to the 2x squared. Okay? Yeah, you're just integrating this, not the e. So 4x squared divided by 2, 2x squared. Okay, that's it. So y to the fourth, because 1 minus, right, n, I'm just going to put an n here just to make it absolutely clear. N, oh man, n equals 4. No, n equals minus 3, sorry. So 1 y to the fourth equals, it's going to be the negative of this, right? Because you got a negative here. So it's going to be e to the minus 2x squared times the integral of 4q of x. So the 4q of x is just going to be this stuff, 4x e to the minus x squared times the integrating factor, which is e to the 2x squared. All right. Yeah. X. Why? Let me just think here one thing. Yeah, this is right. Okay. So anyway, it's going to be 1 minus n times the q of x, which is x e to the minus x squared times the integrating factor, which is e to the 2x squared. Okay. Now this, I'm just already gonna take care of this thing here. This is a 4, it's a constant, so I'm gonna put it here outside. And here you have e to the 2x squared times e to the minus x squared. So it's 2x squared minus x squared is just going to be x squared. Okay, I'm just going to erase this thing. I'm going to erase this minus. Okay, and then you have a dx. Alright, so this is going to be equal to 4. You see, I'm already going to do this thing here. I'm going to integrate and, okay, this is going to be equal to 4e to the minus 2x squared times the integral, right? Now let's integrate this. It's going to be e to the x squared divided by this function, 2x. So divided by 2x. And you do have an x in here. So you got an x in there. Okay, this x is this x. Okay, so these two are going to cancel, and that's what you have. So it's 4 to the e minus 2x squared times the integral, right? Which is going to be e to the x squared divided by 2 plus c1, okay? Or plus c. Let's just do that. So let me think. So here you're multiplying, right? This is going to be equal to what? This 4 is, let's say, I'm multiplying these two, okay? So it's going to be 2 because this one cancels with that one. And now you have multiplying, so you have to sum it up. Minus 2x squared plus x squared is minus x squared. So e to the minus x squared, okay? Plus 4c, because this 4 is going to multiply with this c. But maybe the 4c is just going to become another c, but hey, I'm going to leave it there. 4c e to the minus 2x squared. So let me just think here. Yeah, and this is a z, okay? You gotta remember that this is not the final one. Remember, this is y to the 4th. So if you want to find y, you still have to take the 4th. Y is gonna be equal to this thing here. So 2 times e to the minus x squared plus 4c e to the minus 2x squared. That's what I'm saying. That's what the book considered. Okay, 4 times c is just another c, so just leave it as c. Okay, and gotta erase that. Okay, so y is actually gonna be equal. This is too large. Like this. I'm gonna drag it down here, and I'm gonna say, because it's the index is positive, okay? I mean, it's even. The square root's got to be plus or minus, so it's got to be plus or minus not the square root, but the 4th root. So I'm going to put this thing in here, and this stuff is going to be a 4, okay? There's going to be a 4. So plus or minus the 4th root of 2 times e to the minus x squared plus c times e to the minus 2x squared. That's the general formula of what? Of this equation here. And now we're almost finishing. I just want to do this. It's just a summary, okay? So if you have separate variables, what you have is you're going to put all the x terms along with being multiplied to dx, and all the y terms being multiplied to dy. You got a homogeneous, right? Where m and n are nth degree homogeneous functions. I don't know if you remember, but the homogeneous one is when you substitute x for tx and y for ty, okay? And the f of tx and ty are going to be equal to t to the n times f of x, y, right? That's the thing. And there's something else too. In order to solve this homogeneous one, you got to remember that, for example, you have y, x, and y, right? Because you have the f of x and y. So you have x and y, but here's the thing. The y, not equal. The y, you're going to consider it a vx, where v is a function of x. So it's a function of x times x, right? So the x's are going to remain the same, but the y's, you're going to substitute them for v and times x. And dy, let me just undo this thing. And dy is going to be equal to, well, if it's vx, so it's going to be v dx, okay, plus x, and then you do this v prime, where what do you have? It's got dv dx, right? That's what you're going to do. Oh, actually, it's not going to be v dx. You see, y is vx, right? Y is vx. So if you try to take the derivative of this, dy is just going to be v times the derivative of x, which is just 1, plus x and v prime, where v prime is actually dv over dx. And then you separate these things, okay? dv is going to go to one side, dx is going to go to another side. That's how you solve this homogeneous thing. The linear one is the one we just did, all right? The linear one is just like the Bernoulli one, except that in the linear one, the n here has to be 0, right? It's the same thing, y to the 0 here being multiplied. So that's it, guys. We're going to go to another topic on the next video, all right?